Hello, welcome to 13 Universal. As we continue in A-level CI biology, the exam is around the corner. The May June series, and we wish you the best. Okay, this is immunity paper 2 series 2, and I am Shedro. Okay, let's roll together. Get your writing materials and try this question, my guys. It's time to fry fish. Okay, so we are solving. Remember, it is do it by yourself. Don't depend only on what I'm interpreting, but just first of all try it out. Okay, so vaccination can be used to prevent the spread. So people are vaccinated to prevent the spread of cholera. The vaccine used contains part of the cholera gene molecule. Cholera gene is a toxin and also contains dead cells of V. cholera. Okay, this is one L typo here. Phagocytes play an important role in the immune response to a vaccine. Phagocytes, okay, contains many lysosomes. They say describe the function of lysosomes. Anytime they say describe tells us how does lysosome function. Okay, pause the video and then respond to this question, guys. Okay, so if you remember how lysosome functions, pause it. Is a lysosome contains hydrolytic enzymes. Remember, so it contains what? Hydrolytic enzymes. Okay, so lysosome usually, if I were to describe it, you start by mentioning that it contains hydrolytic enzymes or hydrolysis. Okay, you can give examples of these enzymes like lipase, which breaks down lipids. Protease breaks down proteins. Nuclease breaks down nucleic acids, and of course carbohydrates breaks down carbohydrates. So you see, now you see this guy bought up. So you can see he bought up from Golgi, and then when it bought from Golgi, it now fuses with phagosomes or phagocytic vacuole. Okay, so this is phagosome containing the pathogen. See, phagosome has just been formed by engulfing. So lysosome fuses with phagosomes and releases digestive enzymes, which then break down the pathogen. Okay, all these different enzymes work on different molecules, and of course, lysozyme breaks down peptidoglycan. Right? So see, can you see it here? Any two. So that's what Laskim says. Breakdown, that's the rule. The guy breaks down, digests pathogen or foreign materials. Okay, it contains hydrolytic enzymes, hydrolysis, fuse with phagosomes. That's what it's doing here. It's fusing with phagosome. It fuses with this. This is lysosome, fuses with phagosome. Phagosome is a vacuole that contains pathogen that's pathogen inside and then releases, all right, the enzymes. Okay, because they say we should describe those 2 marks. So just the advantages of having a vaccine that includes dead cells of V. cholera and part of the collagen molecule. Now pause the video and try to solve this question. What's the advantage of having dead cells of V. cholera? Okay, dead cells. Now the first advantage is because the cells are dead, so they do not spread and therefore do not cause infections. Right? They do not spread, they are dead. Okay, they don't cause infection. Right? Of course, we're talking about part of the cholera gene. So now the cholera gene is a toxin, so the toxin does not destroy the body tissues. Okay, because it's part of it cannot function well. Right? So another advantage is that if you're injecting 2 of them, you're injecting this cholera gene is already, remember that vaccine is just injecting a preparation that contains an antigen or the dead or attenuated weakened pathogen. The purpose of vaccination is to form immunity, okay, to develop immunity, and it follows the same normal process of immune response, just to trick the body immune cells, right? So here we have 2 antigens or more than 2 antigens. Part of cholera gene is one. Then V. cholera has many antigens, right, on it. Okay, let's assume it has one, but many antigens usually there. So because we have these two, okay, so there will be more than one immune response occurring. Okay, so more memory cells, different memory cells will be formed. different B lymphocytes will be selected, and different memory cells are formed, different antibodies are formed, which bind to different antigen on the V cholera and then on cholera gene. So there's better immune protection, right? There's better immunity form. Look at it here. So any form of this, of course, we say that dead cells so this cannot reproduce, only part, so not toxic effects. So you see, because we're having cholera gene and V cholera, so now this is already an antigen on itself, so it's non-self, it's going to trigger immune response. This is also having other antigens on its surface, they are triggering immune response. So recognize or trigger clonal selection of more than one type of B lymphocyte. Okay, so this is triggering selection by a particular B lymphocyte, and this is triggering or stimulating, right? All right, selection by different B lymphocyte too. So we're having more, and then of course that will stimulate production of different antibodies. Can you see? You know, during immune response, guys, it's good to remember this. The first is antigen presentation by phagocyte. The second is clonal selection, right? That is the lymphocyte that has specific receptor that fits the antigen is stimulated, and then they go into clonal expansion, which is mitosis. Okay, after that they differentiate, and then the different responses occur. So now, because different lymphocytes are being stimulated, so different antibodies will be formed, and of course that's not the production of more than one type of memory cells. Yeah, and then the immune system can respond to bacterial cells and toxins. So that's the advantage, right? In another question, they can ask you disadvantage. The disadvantage to these guys is that it could lead to side effects, because if you have more than one immune response occurring, because one particular antigen stimulates an immune response. So if you have more than one, like we have here, right, that could lead to side effects, right? Serious, immune immuno allergic reactions occurring. But this is advantage. Okay, different antibodies, different memory cells from, so the bacteria, immune system is well equipped to immune cells are well equipped to respond to bacterial cells and toxins produced. So you're good to go. So different antigens on the surface of cells, that is it. So this V cholera has different antigens on its surface. So we have different antibody formed against each antigen, right? So have lot of protection. 2 marks. Now, a person with HIV/AIDS has a weakened immune system. Weakened. Why? This is because HIV infects cells of the immune system. In particular, T helper lymphocyte, that's the target site. Target site is T helper cells. The pathogen can remain inactive within host cells. In some people, the pathogen becomes active and causes the number of T cells to decrease. So they destroy this T helper. Okay, antiretroviral therapy ART is used to treat people who are infected with HIV, living with HIV. So ART aims to keep the number of T helper cells at a healthy level. So we want to keep it at a healthy level. Explain why it is important that antiretroviral therapy maintains a healthy number of T cells in a person living with HIV. So what is this question asking you? It's asking you for the role of T helper. Okay, you must connect the context to the content. The context here is asking, why do we need to maintain T helper cell? So the content is, what is the role of T helper cell? So pause this video right now and write down the roles of T helper cells, and the reason why we need it to be maintained. That is because of the role. Okay, let's go on. Now, T helper cell, we need to maintain the level, because why do we need to maintain the level of this? The first reason is because the body, if the number of T helper cells is low, anytime you're answering the question, explain, you say what and why. The what here is that if it is low, the body will be more vulnerable, susceptible to infectious diseases. Okay, the body will not be protected against infectious disease. Okay, HIV/AIDS always cause opportunistic infection. That means that once they weaken the immune system, opportunistic infections can occur. So the body will not be protected. They're less likely. The body is less likely to protect for opportunistic infections or infectious disease. Why? Because less T helper cell means that less cytokines will be secreted. T helper cells secrete cytokines. Know it. And then cytokines stimulate B lymphocytes, okay, to differentiate and form plasma cells and memory cells. The plasma cells secrete antibodies which destroys pathogens, and why the memory cells is very important for the future invasion, okay, for rapid response in future invasion. Now the cytokines also stimulate, all right, of course, the production of the production of antibodies is called humoral immune response, okay. But also we have cellular immune response, where these same cytokines, okay, stimulate T killer cells. T killer cells bind to infected body cells and burst them. It releases hydrogen peroxide that make holes on cells, pathogens, and destroy them, or pathogens or infected body cells, okay. So that means that there will be fewer, if you have fewer T helper cells, fewer pathogen will be destroyed. That's not good. And of course, cytokines also stimulate macrophages, aggressive phagocytosis. All right. So if we have less T helper cell, all of this will not occur. The body is in trouble. Look at it. NA3 T helper cell is low. If it is low, then what happens? Low T helper cell means increased risk of developing infectious disease. The body will have higher risk. Okay. Why? Low level of T helper will lead to less cytokines secreted. See, and the role of it: stimulate activity of macrophages, produce angry macrophages. Okay, so you see, all of this will be affected. T stimulates B lymphocyte, plasma cells, humoral. So less of it will be stimulated. So less active B lymphocyte, and so low concentration of antibodies produced. Okay, stimulates cytokines, T killer, and if less of it, so fewer infected cells killed. Right? So more time, yes, the pathogen has more time to reproduce, okay, because they don't have immune cells attacking them. So they therefore begin to multiply rapidly, and reproduce and spread, attacking different tissues of the body. Okay, guys, that is it. So fewer memory cells, very important. All right, future invasion. Memorize this. These are very important. Okay, yeah. Vaccines used to control tuberculosis is known as Bacillus calmette-guerin. The vaccine contains live bacteria that have been selected so they do not cause disease in humans. Fig 5.1 shows a macrophage that is in process of engulfing. Okay, this is a macrophage. The guy is engulfing bacteria in vaccine. This is a macrophage. Okay, so engulfing and digesting this pathogen. So the question says describe. Describe shows how, what, and how. The event, that's the key major event features, okay, of event occurring that occur in the macrophage that has engulfed the bacteria until the production of antibodies in response to the BCG vaccines. So now, what are they asking you to say? They're asking you to say immune response, humoral. What they're asking you is humoral immune response, because antibody is going to. Okay, this question is asking you to describe humoral. How does macrophage stimulate, right, the production? Of course, what does it lead to production of vaccines? So remember, in biology, you must be able to remember the context, understand, but memory is very key. And then you start matching the context with content. Yeah, so what are they asking me here that I already know? They will not ask you what you know. You must have been taught, okay, whatever they're going to ask you, guys. It's not hard, okay? You can do this, you can do it, right? So now remember that one of the things, the macrophage, they're asking us what happens. So when macrophages engulf, so let's start from that, okay? From the activity of macrophage to the activity of B lymphocyte, okay? So macrophages engulf pathogens, and the lysosomes in macrophages fuse with the phagocytic vacuoles containing the pathogens. right? And then the digestive enzymes released by the lysosomes break down the pathogens. Okay, enzymes like lipases that break down lipids, proteases that break down proteins, nucleases that break down nucleic acid, lysozyme that breaks down peptidoglycan, and of course carbohydrates that break down carbohydrates, all the bonds in them. Okay, so now, but that's not all. So they digest the bacteria intracellular in here, but they also um you know move their antigens to their surface. Okay, so macrophages now carry out antigen presentation. They present the antigen of the pathogens to lymphocytes. So if it is presented to T helper cells, the T helper cells will secrete cytokines which stimulate B lymphocytes to divide, carry out clonal expansion, and then forms plasma cells and then memory. So plasma cells make antibodies. Okay, now if they are exposed directly to B lymphocyte, the same B lymphocyte will divide by clonal expansion, mitosis undergo clonal expansion, and then differentiate to form memory cells and plasma cells, which then secrete antibodies. Look at it here, guys. All right, mature B lymphocyte plasma cell process secret. Yeah, that's what. So fusion of lysosome releases. So inside the macrophages, so lysosome fuses, releasing hydrolytic enzymes. So intracellular digestion. Okay, hydrolysis, cell wall component proteins, nucleic acid. So this is broken down, by protease. Okay, this lysozyme, nuclease, lipase. Okay, processing antigens to present on cell surface membrane. So macrophages, antigen presenting cells. See it? Yeah, APC, guys. Antigen recognition, binding by lymphocyte or T lymphocyte, clonal selection, receptors complementary to antigen. Okay, so you must mention clonal selection. So the B lymphocyte, whose receptor is complementary to the antigen on the pathogen, is selected, right? So antibodies are produced. Clonal expansion, proliferation, divides by mitosis. Okay, B lymphocyte mature to form plasma cells that secrete antibodies. If it's T helper cells, they release cytokines that also stimulate humoral, right, or B lymphocyte response. So humoral response to B lymphocyte response, which leads to production of antibodies. Because the question is asking us for the production of antibodies. Okay, so guys, 5 solid marks. Don't play with it. Vaccines such as BCG stimulate the formation of memory cells. Explain the role of memory cells in the body's defense, okay, against TB pathogen. What is the role of memory cells? Pause the video and try this out. Okay, exercise the muscle of your brain cells. Try it out. Okay, so explain the role. So I would say that the role of memory cells, because memory cells stay longer in circulation, they provide long-term immunity. Yeah, they stay longer in circulation. They do not die, just like unlike plasma cells that die. So the memory cells keep the track record of pathogens, or they keep immunologic memory. Okay, why? So that in secondary immune response, there can be rapid or faster immune response, so that large quantities of or higher concentration of antibodies will be made. Remember that in future invasion, the memory cells will differentiate to form plasma cells and more memory cells. So we have more plasma cells now secreting more antibodies. So once we have more antibodies being formed, okay, so more of the pathogens are being destroyed, and the person is not affected. The pathogens do not spread, they don't cause damage. The person is now immune. Look at it. Long-term immunity. B and T memory cells remain in the body for a long time. Yeah, memory cells, they are made ready for secondary immune response. Secondary immune response faster, more effective. So higher concentration of antibodies, quicker production of antibodies. Idea of more specific memory cells in the body than C. Increased chance that pathogens encounter more rapidly. So pathogens encounter more rapidly lymphocytes, okay, and the pathogens destroyed before symptoms of illness. So if you are in the midst of people and they're all having, they have an infectious disease, and you're not having it, probably you must have had it before. and then you must have been exposed to that pathogen. Your immune system would have been exposed to it, and then more memory cells would have been formed. So you're not having the symptoms because your body has memory cells which are responding fast. More antibodies formed that destroying the pathogen. So you are not feeling, all right, not having the symptoms. Probably that's it, the explanation to it. So just why vaccination with BCG has not yet eradicated TB. All right, TB. Pause the video. Why is it that the BCG vaccine is not working? It's not working. Has not yet fully eradicated BCG and tuberculosis. Why? Okay, what are the biological factors? What are the social factors or the economic factors that actually makes this not to work? Let me start from biological factors. Now, TB pathogen is an intracellular parasite. It's an endoparasite. So they live inside the host cell, so beyond the reach of antibodies. So antibodies cannot reach them. They hide inside the host cell. Okay, right? So that's one of the reasons. It's called antigenic concealment. These guys hide inside the host cell. All right, and of course, now most times, of course, another biological reason is that because they change the antigen, and that's antigenic variation. Okay, so that means they will need more vaccines. Okay, all right. If you go to social factors, another social factor is why is vaccination is not very effective in some nations. Not all nations are carrying effective vaccination because maybe they are poor, they cannot afford vaccination program. Okay, right? So that's another factor. Okay, poverty, they cannot afford it. Why is it not effective? Because of ethical issues. Some people do not believe in vaccine. They feel that vaccination can harm them, right, or cause death, right? So they do not take it. And of course, why is vaccination of um, BCG vaccination has not eradicated TB? One of the reasons because herd immunity has not been achieved in some nations. Herd immunity is when larger proportion of the population is vaccinated, so that transmission of this pathogen from one person to another is reduced. Okay. Now, of course, another important reason is migration. People who are displaced move to other nations carrying this pathogen. All right, civil unrest is part of it. Look at it. All right, please memorize these things. It's an intracellular parasite, lives inside the host cell. Antibodies have no effect on bacteria inside the host cell, only when bacteria and plasma cells. Okay. Idea that vaccination is not a global occurrence. It's not global. Why? Not part of the vaccination program in many countries. Right? They don't have the money. Only some countries have as part of their vaccination program. They can afford it. So more economically developed countries have this always. Less economically developed countries don't have this except they are aided by more economically developed countries. Okay, the government cannot afford it. So why can't their government afford it? Because of corruption. Now BCG is not very effective for adults. Some people do not respond. So some people naturally do not respond to it. BCG does not have the same effectiveness across the world. Why? Okay. All right. Many countries have no herd immunity. So do have enough people that are immune to prevent spread. So don't have enough people that are immune to that's herd immunity. So see, civil unrest, civil disturbance like war or civil unrest collapses the health services. People are not able to be vaccinated well because of political instability, civil disturbance. Travelers or tourists, immigrants, displaced people infected with TB and transmit to host population that does not have a vaccination program. So they move to your country with this. If you don't have vaccination program, they give it to your people. Yeah, it's good to do humanitarian activity, but have these systems on ground. Now, the Bacillus calmette vaccine is the only vaccine used to provide protection against the infectious bacteria disease tuberculosis. Most countries of the world have BCG vaccination program. Countries are classified by the World Bank into one of the four, all right, in income groups. Table 3.1 shows the estimated incidence TB for right 2012 to 2020 to 2016 for these income groups. The incidence represents the number of new cases of TB occurring per 100,000 people in 1 year. The new cases include the number of cases that have occurred again after a period of recovery. Relapse TB. So after relapse, they show up back again. That's dangerous. Look at this figure, table 3.1. Describe the pattern and trends shown. What are the patterns? Pause the video and try it. Okay, what patterns do we have? So you see across the years, can you see that in each of the income groups, okay, the incidence decreases. So for example, you see low income, if you move across it, 253, 244 in 20, all right, can you see from 2020, 2012 to 2016, it has decreased from 253 to 2. The same thing with lower middle income, all right? There's decrease across, all right, the income group over the years, okay? All right, that's one trend. And that trend is that in each income group, all right, so can you see in each year, there's also a decrease. For example, 2020, 2012, there's a decrease, okay, across the income group, the same thing here, right? These are general trends. If you check specific trends, okay, if you check these trends between lower, middle, and upper, can you see the decrease is quite much in each year. The decrease is quite much, right? There's a high decrease, okay, between lower, middle. Can you imagine 244 to 8? So it describes the general trend, describes specific features. You can cite or quote data. All right, can you see also from upper middle to high middle? But if you check across the years, there's less decrease for upper middle and higher middle. Okay, across the years, incidence decreases less. 84, 81 isn't okay. All right, let's see what I said, guys. Decrease in incidence over time for all groups of sensitivity. Decrease in incidence over time for low or middle, all of that. One example, large differences in incidence between upper middle, okay, income and low middle. Large difference, can you see that? Upper decrease in incidence with income group increases for each year. Yeah, so it's increased for each year. Decrease in incidence with income, okay. Yeah, general overall self-2015 low 2. Low and lower middle similar incidence, yes, from here to here. All right, okay, similar for you is that's low. Can you see low, middle, this and this similar, okay, same thing here. Okay, just for the trend, 3 marks. There is evidence that the BCG vaccine has also provided protection against the disease leprosy. Yeah, leprosy is caused by a bacterium that is closely related to the bacteria that causes TB. So just why the BCG vaccine can also provide protection against. Why is it able to provide, all right, protection against leprosy? So if somebody is vaccinated with BCG, which is the vaccination against TB, why can it still protect them from leprosy? Pause the video and solve this question. Okay, try it out. The reason is because you know that the antigen of leprosy and TB, the antigen on their pathogens, okay, bacteria, for leprosy and TB are similar. The antigens they have similar shape, okay, so they have similar shape. Why? Because they have similar genes. So the similar genes code for similar antigens. So because they have similar antigens, therefore the memory cells produced against TB pathogens can bind or recognize, all right, the leprosy pathogen. Okay, the antibodies can also bind to it and they can destroy it. Look at this, guys. It's not rocket science. See antigens. Leprosy bacteria has similar shape. Okay, so memory cells recognize or bind antigens on leprosy bacteria because that of antigen has similar shape, right, with tuberculosis. So memory cells can recognize and bind to it. Antibodies can also bind to it. Now, why is this happening? Because both the TB pathogen and leprosy, they have similar antigens, okay, similar genes, so to synthesize similar antigens. All right, a baby can gain artificial active immunity to TB after having the BCG vaccine. A baby can also gain natural immunity from the mom to TB. State the differences between artificial active immunity and natural passive immunity. Pause the video and try it. What is different between active immunity and natural passive? Okay, so active immunity, artificial active immunity, is deliberate, is injected by health officials. This is not intentional, it's not deliberate. From mom, passes from mom across the placenta and through the breast milk. All right. So now, remember, immune response occurs there, but there's no immune response in natural passive, right? But active immunity, immune response occurs. So memory cells are formed in active, not artificial active immunity. There's no memory cells formed here. However, um, this takes time, slow. Artificial active immunity, but natural passive immunity is immediate. While artificial active immunity is long-lasting, natural passive immunity is short-lived. So you see the answer here. Memorize it, guys. Okay? Deliberate, not deliberate from breast milk. Okay, so you see vaccines are injected here, antigens, right? While here antibodies pass on. So the antibodies are made by the baby in artificial active means that the immune system can make their own antibody. That's active. They have memory cells. Passive means that they cannot make their own antibody. The antibody is from another organism. So in this case, the antibody is from the mom. Okay? Here, the baby has developed this all right, ability to make its antibody. So it's antibodies, memory cells produced. Here, no antibody or memory cells produced. The baby is dependent on the mother's immune system. Long-lasting, short-lived for, natural passive. Protection not immediate for artificial, immediate for artificial. Okay, that's 3 marks. Thank you guys for hanging on. So expect our videos on other topical like infectious disease and other technical topics, both for paper 2 and paper 3. So this is Shedro from 13 University. Bye. See you later.